Hi, everybody. I apologize for not being with you today. I'm actually in school right now. It's the morning, and I'm preparing this lesson for you so that we don't fall too far behind. My son Joseph is sick, so I have to get home to him by around 12. So I am missing class with you today, but I wanted to make sure that we, again, didn't fall behind. So the first thing that we're going to do today is we're going to go over this homework sheet that you had completed last week. So as you recall, I assigned this last week. It was 9.1 reading and then answering the questions. As you remember, you did not have to submit this to me, and I said that we would go over it in class. But since we had lab yesterday, we were not able to, so we're going to do that right now. After we go over these questions, the next part we're going to do is we're going to work a little bit on our notes and fill in some blanks there so we are progressing with our notes. As a reminder, you should have your compass with you. Hey, remember I told you last week that you need to have a compass in order to triangulate the epicenters. Okay, so we're going to start working with those on Thursday. If you have it with you tomorrow, you can bring it in with you tomorrow, because that was the original due date. But everybody should have their compass with them for Thursday, because we're definitely going to start to work with them on Thursday. Okay, so let's just get started with this. This is going to be our answer key. So if you have not done so already, just open this up and we will go through the questions. So I'm going to just tell you the answers because I don't want to waste too much of our time together. And since I'm not there to go over each individual question, I'm going to give you the answer key right now. Okay, and then tomorrow, if you can, hey, just put a little star next to questions that you get wrong, and then I can answer any individual questions from you. So, for example, number 1, hey, is true. Hey, and, oh, why isn't this writing? Hey, number 1 is true. So, for example, if you got this wrong and you put false, hey, and you don't know why, you're going to put a little star next to it to remind me to ask or to answer questions tomorrow about that. I'm going to switch styluses here because this one's not working too well. Okay, all right, so number 2 is false. Is this going to work? Oh, nope. Okay. Number 3 is true. So as I'm giving you the answers, you're checking your work, okay, and just making sure that you have the right answers. Okay, so far it's true, false, true. Number 4 is false. Okay, number 5 is false. Number 6 is false. Number 7 is true. Number 8 is false. Number 9 is true. Okay, and 10 is false. Okay, so once again, just put a star next to any of the questions that you got wrong. And if you got something wrong, I can answer any individual questions tomorrow and explain them to you. Okay, then the next part has the definitions, and you're just picking the words, and the rest of the list is on the next page. But I know you did this already, so let's just go through it. Hopefully everybody got this right? Vocabulary is super important. So number 1 was G, number 2 is D as in dog, 3 is B as in boy, 4 is E as in Edward, 5 is A as in apple, 6 is C as in cat, and 7 is F as in Frank. Okay, so now what we're going to do is we're going to transition to the notes that we started working on last week. So I'm just going to progress the presentation here. So this was the rest of the terms for the questions on the previous page from homework last week. This is where we're up to now with our assignment, and we're going to continue to chip away at the notes. This is going to be the focus for the rest of the period. I'm going to keep you for about 10 more minutes, and then you can work on your homework that I had given you on Friday, and then also just make sure that your lab is complete. So you will have some time at the end of the period to make sure that you tie up any loose ends that you might have. Okay, so this is where we had left off with, and we are going to start talking about body waves. If you remember from the last chapter when we started to talk about plate tectonics, we introduced body waves. So hopefully everybody's remembering that we talked about body waves, and if I was in class, I would ask you the questions of what types of body waves do we know about, okay, and the first one you would say, hey, is P waves, and the second one is S waves. So this section is going to be a bit of a review, because we did do this in the last chapter. And as you know, I've said a few times now, these next few chapters are building on each other. So we did plate tectonics. Hey, we're talking about earthquakes, we're talking about mountain building, and we're talking about volcanoes. And all of these topics are connected back to plate tectonics. Okay. So the first thing here is waves that travel from the focus of an earthquake through Earth that carry energy. So hopefully everybody remembers that the type of energy that we're talking about is seismic. So seismic energy is what we're discussing. Remember from the other day, we said that the focus is inside the Earth and right above it is the epicenter. And that's what we're going to be locating on Thursday, again, when we triangulate our circles. Okay? And that would be where our epicenter is going to be. And I'm going to teach you how to do that on Thursday. So we're saying energy that's coming from the focus. There's two types of energy that come from the focus, and they're the P waves and the S waves, and they do leave at the same time. Okay, they leave at the same time. So as soon as the earthquake happens, as soon as the release of energy occurs, the P wave and the S wave leave at the same time. But hopefully everybody remembers that one of them is a little faster than the other. Okay, so if I was in class, I would ask you which one is the fastest, and everyone would definitely say the P wave is the fastest. Okay, so the P wave is going to be faster than the S wave. As you remember, we have the P wave that is a compressional wave, kind of like a slinky, right? So we're going to close the slinky. I showed you that picture of the block of rock, hey, getting compressed, and then it stretches back to normal once the energy passes through that rock. So we have P waves, okay? So P waves are compressional waves. They're also known as primary waves, okay? Primary, meaning that they are going to be received by the seismic station first. So they're going to travel the fastest, and then when they are recorded at a seismic station, they will be recorded first because they are the fastest. So we say that they're P waves. Hey, we call them primary waves, and they're going to squeeze and stretch the rock materials as they pass through the earth. And as you recall, they can travel through any material. So that means it can go through solid, it can go through liquid, and it can go through gas. Yesterday in lab, we did our deformation lab, and we talked about the different materials. We talked about silly putty. We talked about a spring. So hopefully you are recognizing that a P wave would be similar to that of a spring in that you can kind of close it and open it, or a slinky that you can close and open it. Now, we're making the connection of the materials that we had in front of us in lab, but as you recall, the materials we had yesterday in lab were really trying to say, well, how did the rocks respond when the seismic energy goes into the rocks? And that's what we're building on. Okay, so as we go to the next slide here, we're going to talk about the second type of wave, right? So now we already did the P wave, which are primary waves, and they're the fastest waves, and they can travel through anything, solid, liquid, and gas. And then the second wave that we're going to talk about now is my S wave. Okay, so we're going to add this to our notes. We have our S waves. S waves are known as shear waves. They are also called secondary waves. Okay, so remember the P wave is primary, meaning first, okay, and then secondary, obviously, meaning second. And I always use the example of our education. So when you are in grade school, you can also call that as primary school, grades like kindergarten to 6th grade, or even higher in some cases. And then secondary school would be where you're headed next year, 9th grade, 10th grade, 11th grade, 12th grade, so that comes second. So what do the S waves do? Okay, they're going to cause the particles of the rock, okay, to move at right angles, okay, perpendicular. Remember, we've talked about perpendicular to the energy. So as the energy is going through the rock, and if we have a wave traveling through the rock in this direction, that means that the rock is going to go up, and it's also going to come down, creating this right angle of motion. As opposed to my primary wave, which is just straight through, and it's going to squeeze and stretch the rock as it goes through the rock. I have another picture to show you on the next slide or two, and that will make a little bit more sense. As you recall, we said that S waves can only travel through solid. So hopefully you guys are realizing there's little tricks to remember this. Okay, S wave is for secondary. Okay, S waves, okay, is only going to travel through solid, right? So S for solid, S for secondary, and then also S for shear, okay, shear waves. So then kind of moving along, okay, we have, I'm going to pause that for a second. My phone's ringing. Hold on. Okay, I'm back. So this part now, let's just discuss real quick. There's really no blanks to fill in here. So the rate that the P and the S waves move, the rate that the seismic waves move will depend on the type of material that they travel through. Okay, so we can have rocks that are brittle, as we learned yesterday. We can have rocks that are ductile, and then fast forward, okay, to the mantle. Now we're dealing with a completely different substance. So we can have brittle rocks, and then we can be in the asthenosphere. Remember, the asthenosphere is the slush-like layer of the mantle, and the P wave and the S wave will move differently depending upon the material that it's coursing through. So waves travel faster through rigid, okay, and dense material. Okay, P waves travel faster than S waves through solid material. So hopefully that makes sense to you. Okay, we've already talked about this part, right? P waves are faster than S waves. And I always compare it to riding your bike. So if you and your friends are traveling down the street, okay, and you go in a straight line, so this is you on your bike and you're on the concrete. Okay, and then your friend is on his bike and he sort of meanders, okay, down the street. Again, on the same substance, you're on concrete, he's on concrete. So he's going to take a longer time to get from point A to point B, okay, than you. Remember, the quickest way to go from point A to point B is a straight line. So this is what we're talking about as far as P waves go, okay, because this is compression and this is shear, and they kind of go like a snake. Here's another S word, like a snake. So it's a little bit slower. Oh, another one, slower. Okay, slower. So lots of different ways, lots of different tricks to remember the difference between a P wave and an S wave. So then let's just focus on this. Same thing. You're here, you're going down the street, okay, and you're going on concrete. Okay, your friend is going down the street and they're going on mud. Okay, well, obviously that's going to take a longer time for your friend to travel down the street on his bike if he's traveling through a substance that is not rigid and is not dense. Whereas you're on the street or concrete, you're going to have no problem getting there. Okay, so hopefully that makes a little bit of sense. And we're going to apply what we know in everyday life to how the P waves and the S waves work with earthquakes, which is a little bit more abstract for us because we don't actually witness that ourselves. But that's what we're uncovering and making those connections. Hopefully that makes sense. All right. So then when you have a P wave and an S wave, those are called body waves. The P waves and the S waves will turn into surface waves. So let's just make that distinction. Okay, we've been talking about body waves. Inside the body of the earth, two types of body waves, P and S. Now we're done talking about P and S waves, and we're going to focus on surface waves. The P waves and the S waves will turn into surface waves. So once the P waves and the S waves leave the interior of the earth and are now traveling on the surface, guess what? They're called surface waves. So when we talk about that, okay, that's pretty obvious that if we're on the surface, they're called surface waves, and there's two types. So two types of body waves and two types of surface waves. The first one is called a love wave. A love wave. What does the love wave do? Okay, the love wave is going to travel through the surface, through the rock, maybe through your yard or a neighboring yard as it travels through the surface. It causes particles to move side to side, and here's that word again, perpendicular to the wave's direction of travel. Perpendicular to the wave's direction of travel. So as it goes through, it's throwing the rock up, and it's also throwing the rocks down, okay? And so it creates this right angle of motion. I'm going to show you a picture of it so it makes more sense on the next slide. The second type of surface wave is something called a Rayleigh wave, okay, or a Rayleigh wave. I've heard it said both ways. So the Rayleigh wave is a little bit slower. Okay, so the love wave is faster. The Rayleigh wave is a little bit slower. And it travels, or causes, I should say, the material that it goes through to move in an elliptical pattern. I always compare a Rayleigh wave to skipping a rock on water. So it's creating this elliptical motion. Okay, so that's going to require more energy than, or I should say, hence is why it's slower. That is why it is slower. So Rayleigh waves are slower than love waves. If you were to kind of compare which is which, the P wave is more closely connected to a love wave, whereas the surface wave is more connected to a Rayleigh wave. So we have body waves and we have surface waves, and we are chipping and we're almost done for our notes today. As promised, here is the images. Let's just focus on this. Body waves, number 1. P waves. As you look, you have the hammer. This is the stress. That's the strain. Okay, you're going to hit the bottom of the block of rock, and you can see that the block of rock is divided into cubes. And as it does that, you can see there's a white arrow here and then black lines showing you where the energy is at the current moment. And then here you have it in this spot, and then this spot, and then this spot. So the direction of motion of the energy, the seismic energy, is going straight up. And as the energy goes straight up, hey, it's contacting the rock and squeezing it. And then once it passes through it, hey, it's going to stretch it out. Second wave, hey, is the S wave. So we have this sheer, snake-like, wiggly type of reaction, hey, to the motion that is set forth by the hammer. Okay, so when you look at it, you can see that it is not going to be as straightforward as my P waves. It makes it wiggle a little bit. It's displacing it. And that's my S wave. That's my shear wave. That's the snake-like motion of the rock. So that's my body waves. Okay, and then lastly, my surface waves, as we've mentioned. Now you're on the surface, so it looks a little bit different. Pretend that your house is here. What would happen if the energy goes through the ground on the surface? My love waves, here you go, perpendicular, up, down, up, down, up, down, and creates this right angle with respect to the energy that's coursing through the surface. So that's my love wave, surface wave. As I said to you before, the Rayleigh wave is very similar to that of the S wave. The only difference is it's on the surface. So you have this snake ripple-like motion, kind of like a water wave. Okay, so we are going to stop there. Okay, this is going to be our starting point for tomorrow. Okay, measuring and locating earthquakes. So just as a quick reminder, hey, you should have your compasses with you for class so that we can draw our circles. Definitely by Thursday. If you have it with you tomorrow, you can bring it with you tomorrow. Okay, reminder that your lab is due tomorrow as well from yesterday. Most of you finished it, okay, but any finishing touches should be submitted to me by tomorrow during class. Next, you had the 9.2 reading and questions. So remember on Friday, I gave you the questions, but you weren't able to open them. And then I put the PDF version in there for you. So that is in there. And I had given that to you over the weekend. So some of you have actually already even submitted that. Lastly, your extra credit, plate puzzle is also due tomorrow. So there's a few things that you should be bringing with you tomorrow. Making sure your lab is done, 9.2 homework, and then your extra credit plate puzzle. Okay, if anybody does have any questions, I will have access to my email all day today, so please don't hesitate to email me, reach out, and I will get back to you as soon as I can. All right, I will see you all tomorrow. Thank you very much. Bye.